Hi guys, this is lesson 8.6 and it is the last one from chapter 8 with similarity, and I love this one because it brings in proportions and stuff that we know, but you know, let's make sure first of all that you help me with my typo. I forgot to put E right there, so if you don't mind putting the E there, that would be very helpful. We are going to discover the rules for today's lesson. All right, we're going to figure out, and we're going to use the fact we have similarity ratios, okay? And we're going to use the fact these two triangles, which are both equilateral, that they are going to be similar to each other. And we talked about that before, like in our notes. By AA similarity alone, these two are, because they have all these 60-degree angles. Or we know the ratio of the corresponding sides are always going to be the same. So that works. So what you would be doing in class is I'd be, all right, guys, first of all, you would have to decide, are the two triangles similar? And what would you say? We'd say yes. Why? You could say by side, side, side similarity, or by AA similarity. And by the way, AA, I want to say in there because 60-degree angles, okay? And we know they're all there. Then I asked the question, what is the similarity ratio of ABC to DEF? So you need a pair of corresponding sides. So we'd easily go, all right, AC is to DF, same thing as 6 is to 12. Oh, that's 1/2. Okay, so that's the similarity ratio. Then the next thing I'd ask you to do is find the perimeters. Now, perimeter, remember, and what's perimeter? Like the perimeter of the room is the outside of the room. So we're going to go around the outside. So the perimeter of triangle ABC is going to be 3 times 6. That's 18 centimeters. The perimeter of triangle DEF is going to end up being what? 3 times 12. And that's going to be 36. And then I want the ratio of the perimeters. And by the way, the ratio of perimeters, I'm going to call it RP. We have similarity ratio was SR, ratio of perimeters, RP. All right, so I want the ratio of the perimeters. So the ratio of the perimeter from the smaller triangle to the larger one is 18 to 36. What's that going to be? 1/2. Now I want you to compare, okay? Let's look at 2 and 3. Compare the similarity ratio and the perimeter ratio of the two figures. What's so special about those two? The similarity ratio was 1/2. The ratio of perimeters is, 1/2. What are they? They are equal. So that means I can actually use the similarity ratio to find perimeter and perimeter to use similarity of sides. It's kind of cool. And the reason why this works is because those are linear measurements. So all the linear measurements of a similar polygons are going to have this exact same thing. Similarity ratio, which is the ratio of the corresponding sides, and the ratio of perimeters will always be the same. Now, I sit there and instead of having you calculate the area, I did it for you. I was kind of letting you be lazy a little bit. It says the area of triangle ABC is 9√3 square centimeters, and the area of triangle DEF is 36√3 square centimeters. What is the ratio of areas? So again, ratio of areas, I'm going to call it RA. Go figure. I'm not going to be real exciting. So the ratio of the area of the smaller one to the larger one is 9√3 to 36√3. Now, what does that simplify down to? It's going to be 1/4. Now, is there any relationship to the similarity ratio? And some of you are, well, looking at it, no. I want you to look at it harder. Your answer would be yes. Okay? And here's what it is. Look at your similarity ratio. It's 1/2, right? What if I do this to it? What's 1 squared and 2 squared? It's 1/4. The ratio of area is the square of the ratio, or I'd say of the similarity ratio. It's a better way of saying it right there. The similarity ratio. So basically, all I have to do is square it. Well, think about this. When we talk about area, what do we do to our units? We squared our units. So it's a very easy way for us to see this. So very first thing we're going to do is work with those. All right, hopefully this helps you guys a little bit understand where we're going to go.